The last class was about the structure, discussing the basic structure of the Vhdl code, difference between signals and variables, and the types of ports available and their uses. And we just saw a basic adder program. And today is a lab session where we are going to execute a adder program and this program, and also discuss about some errors we are going to face while simulation. Let's start the program. Yes, new. So remember that black box I told you last time? I think I should have it somewhere in the documents file. Yes. So I need A, B, and C in as inputs, C out, carry out, and C is the sum. And we are going to design a 1-bit adder using Vhdl. Yes, let's do it. Let's do it. So as I told, first the structure of Vhdl should have an entity, and the name should be adder underscore new is, and then we have to declare a port end entity, and then architecture behavioral of adder underscore new is begin and end behave. This is the basic structure of the Vhdl code, and here we are going to write the input and output port, and from the block diagram here, A, B, and C in are the input ports. So A is in is the type of port, which is in out or in out, standard underscore logic, B in standard underscore logic, and then C in is in standard underscore logic. C out, this is an output port, logic, and we do have C, which is nothing but the sum. Okay, C is the sum. And while simulating the file, I just want to create some errors and show you what all errors you can face into. So XX process, we are going to use A, B, and C in as input, so that has to be in the selectivity list. And then after process, I told we have write begin, or Vhdl is going to pop up an error. And now C is nothing but A XOR B XOR C in, and C out, which is nothing but carry out, is nothing but, I'll just copy it from here as it's quite big expression. And then once you start a process, you have to end a process, and that's all about the program. And now let's try to execute this in the Xilinx software. New file in Xilinx, file new project, and this is with this name of new classes CLA SCS underscore YouTube, and just make sure your simulator is set up to the iSim, and synthesis tool is Vhdl Verilog. You can select what kind of family you want. Vertex 6 is better, and finish it off. And now I get this. If I have to add a new file, right click, add source, and then I think mine should be in desktop, new underscore adder. And now, yes, I have some errors. Let's try to solve those errors. Syntax error near end. Yes, I have to close it over here. Use a semicolon. I forgot to put a semicolon at the end and forgot to close the port. And now, unexpected error of function, no semicolon at the end. And yes, I'm synthesizing the file. It's going to take some time, so I'm going to pause the video for a while. It failed. Okay, let's see what errors it has. So, standard underscore logic is not declared. So, what's the error in this program? The error in this program is that I forgot to attach the library files. So, let me attach the library files. Just don't freak out if it says your standard underscore logic is not declared. You might have forgot to use your library files and the error has to go now. And then let me implement the design. Successfully synthesized. And I'm going to pause my video for a while. Oh, sorry. It's Vhdl schematic. And this is how it is. A basic adder circuit. And to check its output, I have to write a test bench for which I'm going to pause a video. To write a test bench, right click the file, right click this, xc whatever, and just say a new source, and then vhdl test bench adder underscore tv, and go for next. And then this is the file for which you have to write the test bench and finish it off. So as I don't have any clocks in my process, I'm going to nullify these statements, otherwise it's going to pop an error for me. I'm sorry. And I don't need this too. For now I'm only going to test one case. A is equal to 0, B is equal to 1, Cin is nothing but 1, 0. Wait for 100 nanoseconds, and the same thing with A equal to 1, just to check on the carry. So just go to design utilities and then behavioral check syntax. Does not have a wait statement. Strange. 88. Error is because of this, as I've not declared the clock statement. Strange. I was seeing the warning, I'm sorry. And now this is the signal. This is what I was missing on. And then syntax error near this. I think it has to be fine now. Let's check it now. Yes. And simulating the behavioral model. And let's see. When A is 0 and B is 1, then C is nothing but 1 and C out is 0. That is correct. And I don't know why I have discontinued the other case. I'm sorry. Let's check this case too. And the other thing, whenever you are assigning a value to a signal, you have to have this sign, not this. If I just try to check the behavioral code again, I would be getting an error saying that syntax error near this, which means I have to assign a weight value to a signal, which is done by this operator, not that. This is going to be quite long, but it is useful. And now we got it. We have the two cases, right? So initially when A is 0 and B is 1, C is 1 and C out is 0, and the next case A is 1 and B is 1, C A out is 1 and C is 0. 1 and 1 is 0. And this is the simulation of a basic adder program. And now let's go on to the creation of errors. What if I don't declare my entity here? Is Vhdl going to pop up any error? Let's see. And now it's going to show a syntax error near architecture. Syntax error near architecture means that see a line above it, which means that I have some problem in this line. So let me just clear this off, and then you can see that the problem solved. And most importantly, when you don't close this braces, it shows that the signal is repeated or the syntax error near end. And